Hi, Chuck. Someone who I thought had passed on to the better lands, but you're very much here, and it is my absolute pleasure to speak to you. Can you introduce yourself?
Yeah, I'm Chuck Bennett. I'm just a guy. I've got a history of engineering and government contracting and government service, and I dabble in physics on my own time. I'm an amateur physicist, I guess you could say. So I've come up with some ideas. I got some I'll share with you this morning.
Wonderful, wonderful. Well, I only came across your name last May. In fact, it was
Uh-huh,
last June, actually. I think on June the 3rd night. I
mm-hmm,
I was going through the affairs that I'd been given, the last 60 kilograms from Dr. Takaaki Matsumoto. His family had given me them. And
uh-huh,
I came across some documents that you had exchanged with him back in
uh-huh.
1995. But before we
Oh,
go on to that, um, I am absolutely stunned when I was reading through New Energy News recently when I came across your proposal that you suggested to your employee Raytheon back on March the 24th, 1989. That was just one day after Martin Fleischmann, who I have been running the memorial project for since 2012 with my fellow directors. And I was absolutely stunned that you had come up with such a fantastic idea. Do you want to just go into what inspired you? Obviously, the announcement maybe, but how you came to make a suggestion that you did and what that was at the time.
that was as I could remember, uh, a nuclear fusion candle was the name of the invention. Raytheon awarded me an inventor's award. It was very theoretical. It's based on warm fusion. You take, say, a metal, a palladium or titanium, and saturate it with deuterium by diffusion. This is accompanied by soaking the metal in a bath of deuterium gas or by electrolysis in heavy water. Then the metal is energized by a high-powered laser. Deuterium atoms are trapped in the lattice and are forced to fuse with other deuterium atoms as they race to exit the lattice, thereby causing a fusion chain reaction. So that's basically the concept in mind. That's what I had in mind when I proposed the nuclear fusion candle.
Yeah, so it's
This
kind of
based
like a
on,
slow burn rather than a very fast supercritical explosion.
uh, I think so. You know, it's all theoretical. I dabbled with some experiments in my backyard, but I wasn't able to energize the metal very well, just a blowtorch.
Since then, of course, it was revealed that in Soviet Russia they had deuterated metal and they could smack it with a hammer and it would produce neutrons. And I remember the very first ICCF I went to, ICCF 17, in Daejeon in South Korea. There was a guy from Texas A&M University, and he had replicated work that I think was done in the early 2000s, where they had deuterated titanium and they had plunged it into liquid nitrogen, and
Right?
that had produced a load of neutrons. Then in 2015, I went to the All Russian Plasma Physics Institute in north of Moscow, and I was shown by a researcher there, Sergei Godin, a compressed titanium hydride or titanium deuteride pellet that was then cycled with heat and induction coils, flash induced in the center of a solenoid with a varying pressure of hydrogen isotope gas, producing excess heat. And then more recently, the researchers Luca Gambarale and Giovanni Modenese, the former who was a pupil of Giuliano Preparata, They had deuterated and hydrided titanium, and they showed the synthesis of deuterium from hydrided titanium. So that is very, very important because it's showing that you can get to deuterium. However, what they also saw was the production of massively non-natural isotope argon gas. That is to say,
Argon, huh?
yeah, they saw the production of much higher than natural ratio of 38 argon over the much higher natural ratio normally of 40 argon. In fact, the ratio in the air is about well, it's nearly 2,000 times. It's like 1,600 and something times more 40 than 38. But in their reactor, the argon that was detected with their residual gas analyzer was just less than one times 10 times more, not even 10 times more. So a massive isotopic deviation. So that's more interesting to me than the the deuterium synthesis. Although the deuterium synthesis is phenomenal in its own right, if it comes from that. Now, there's many ways you can get there, but anyway, the point being is that it would turn out looks like it's an interaction between titanium atoms. And if you get two titanium, say 47 or whatever, they can fuse and produce argon isotopes and iron. So I think you get
Uh-huh.
iron 56 and argon 38. In fact, most of the interactions between titanium pairs of atoms produces argon 38, the top ones, and an iron isotope. And so yeah, I mean, titanium was a very. Why did you choose titanium?
Because of the solubility of deuterium in the metal.
Yeah.
I know it's palladium soaks up deuterium, but titanium absorbs more
Uh,
deuterium.
I think I don't know. It's like the most. Yes, you get TiD2. That's true. So the ratio of atoms and I think the nuclear mass, but I think it was Thomas Graham FRS that in 1873 established that palladium absorbs hydrogen isotopes because, of course, deuterium wasn't even discovered back then.
Right.
Higher than any other metal, and it was um, a guy. Oh, I can't remember his name. What's his name? I've been looking at a video from 1998 of Martin Fleischmann recently, and he spoke about this 1927-8 paper, and then a follow-up
Mhm.
by a German researcher that discovered the propagation or the conduction aspects of protons in metals. And
Right.
I think they looked at protons in iron and palladium and showed that they could move around and evolve if they were driven in one direction, and they could immediately be changed direction. So um, that what inspired I in your proposal, did you mention the cryogenics?
At that time, I did not.
And
Mostly,
when did that come? Because I think you gave a lecture around the time that there was a proposal by one of the national labs, right?
well, I approached three national labs about the concept, Lawrence Livermore, Los Alamos, and Oak Ridge, but I couldn't raise any interest from any of them. So it sounded like things have been going on that I didn't know about. I'm really interested in this.
Yeah, so the way I viewed it, piecing what some of the history which I've just given you of in metal deuterides and hydrides, particularly with titanium and signatures of transmutation occurring with titanium hydrides. And your work is that we already know, as you said, TiD2 is one of the highest, if not the highest, atom ratios you can get in a metal lattice. And
Right,
we already know 100% certainly that if you suddenly compress it by putting it in liquid nitrogen, you get the synthesis of neutrons. Now, one might think that that is from a more standard fusion reaction between two deuterons, so that may be one consideration.
Right,
But also you have the situation where Luca Gambarale and Giovanni Modenese have recently published, where they're getting the synthesis of deuteron from hydrogen, and they're also getting other transmutation reactions going on in that metal sample. And so where I'm at right now is you take this extremely solvated proton or deuteron titanium metal lattice and you cool it, and so it's the solvated hydrogen ions are even at a higher compression ratio, so they're already in a difficult state,
right,
and then you drop that pellet and you fire lasers on it. And
right,
you can get these lasers right now, quite commercially, 20-watt lasers, 30-watt lasers for cutting through steel plate pretty darn quickly. They're
uh,
commercially available, and you can buy the laser heads and the drivers for laser cutting plates. And I noticed that you had an article in UNG News around about the time that it kind of shut down, I think in 1989 or 1998 or 1999, where you mentioned that there was this, or maybe it was earlier than that, but you mentioned that, was it Lawrence Livermore National Laboratory? They were looking
yeah,
at using lasers with fuel pellets, although you didn't go into the detail of the fuel pellets.
right.
So what was your understanding of that work that they were proposing, other than the big budget of 1.8 billion?
Yeah, that's true. Well, at that time, I didn't know exactly how things would get energized, but I knew that some energizing is necessary to get things started. So that's where the laser comes in. And I know at least Lawrence Livermore has that capability for laser energizing of the titanium deuterium lattice. So that's what I had in mind. But you're telling me things that I didn't even know about, as I haven't been following it as closely as I could. I guess I kind of let things go to the back burner for a while.
Yeah, so I mean, what we have now is we have proof that just compression from and cooling leads to, and now the cooling could lead to coherence, and the pressure could lead to forcing coherence, um, and so it could be through coherence, and this is where I'm coming from. I believe the process is coherent, but of course, um, if you are any vibration that is a thermal vibration is effectively a phonon in the lattice. And um, if you could hit a particular resonant frequency, which is somewhere between room temperature and minus 77 degrees centigrade, um, or compress it electrostatically, then you might be in a situation where you would actually get the fusion and trigger it. So um, uh, if you've imagined you've already cooled it to, it's highly compressed in there. It's a higher compression ratio than you can compress gas, and then it's compressed by cooling it, and then you hit it with a laser. You've got this situation where the material is trying to expand, and the energy's hitting it at the same time. So you've got like an almost electrostatic confinement type situation
And
going on.
and for a brief instant, the deuterium is encapsulated in that metal lattice.
Yeah.
So these are all dynamic conditions, like you say, that when the deuterium rushes out of the lattice, then there's a possibility of a reaction.
Yeah, so I'm glad you said dynamic, because it is where you have situations that are far from uh, um, stability or far from
Uh-huh.
equilibrium, where you start to see the things that I have seen most of in working systems. and that is turbulence and chaos. And so it
Did you say turbulence? Did you say
turbulence and
turbulence?
chaos, yeah.
Chaos, yeah.
And that's an area of expertise for you, isn't it? And for why?
Pardon me?
You have an expertise in turbulence and hydrodynamics, don't you?
A little bit. I have a superficial knowledge of those, but it's
Yeah.
all theoretical. I haven't applied that in my
So
dealings.
the most shocking thing for me when I came across those documents in Matsumoto's archive was in 1994 through to 1995, late 1995, you were working with someone, and that was Warren Cooley. Is he still with us?
I don't know. I lost touch with Warren Cooley a long time ago. Man, you have really researched the past. That is just totally amazing.
Well, I've been doing this for nearly 14 years, and I really care about finding a solution. So it really matters to me. So in that pattern, were the ideas of endohedrally storing deuterons inside a carbon 60 buckyball?
Uh-huh.
Was that his idea or was that your idea?
That was more his idea.
Hmm. Because some things have happened since then. So I worked with a guy called Dr. George Eagley, and Dr. George Eagley in the 1980s, he claims to be the first Soviet era scientist to be invited into a national lab. And he came over because he'd done 2 decades of research into ball lightning, the natural phenomena of ball lightning. He went on later to develop a dusty plasma fusion device using microwaves in a resonant fused quartz structures inside even a domestic microwave. And this was kind of inspired by both ball lightning, but also the work of George Osawa, which was replicated in the mid 1990s by John Bockris and Sundaresan. And so Sundaresan was on secondment from the Babra Atomic Research Center, and they found that carbon arc discharges underwater synthesized heat commensurate with a predicted production of helium reaction that would marry alongside the iron that they observed being produced. So iron was produced from a carbon in H2O system, and they only saw the synthesis of iron if there was oxygen present. It dissolved in the water. If they boiled it, degassed it, and then saturated it with nitrogen, there was no iron produced. And this points to oxygen being critical in the process of these kind of synthesis processes. The reason I'm saying this is because the reactor that was done by George Eagley, it produces iron and it produces the other elements that were observed by Dr. Osawa. And
Amazing.
yeah, and so I've replicated that, and more recently, uh, a guy called Anatoly Klimov, who created the aerospike or worked on that and is an expert in shock waves. He released that his plasma flow vortex reactor, um, which he claims it produces up to a COP of 10, that he replaced the metal particles with carbon nanoparticles in and it works just as effectively. Of course, you then don't need expensive palladium or any other kind of expensive processes. And this is just any old carbon nanoparticles, not necessarily buckyballs. And the reason is because the carbon itself, and actually particularly carbon 60 and buckyballs, a buckyball doesn't have any free bonds on it. It bonds as pretty much as it needs to. So it becomes a charge aggregator and it can aggregate fantastic amounts of electric charge. Anyway, in this video that he shared within the last year or so, Anatoly Klimov, he showed that he could even create a CC laser inside the open tube without having any confinement and so on. It would actually laze light from CC. And um, so it's obviously in the coherent regime. The interesting thing is on that video where he's talking about this, you can see a date stamp down in the bottom right, and it's from 2001. So nearly a quarter of a century ago, they already knew that you could produce a wide range of elements through stimulated fusion using carbon particles.
Oh, okay, that's amazing. And you say it's any form, not necessarily buckyballs.
Yeah, so basically small
Yeah.
nanoparticles. Yeah, I mean, you could go and buy buckyballs, but like in the case of the microwave reactor, what we did was we actually crushed up normal charcoal and graded it through a very fine sieve. And the actual process itself smashes the particles up into nanoparticles. It makes its own fuel, if you know what I mean. Um,
Oh, yeah.
so, so, so that patent that you did with Warren Cooley, you submitted it in 1995, but the last, when the trail goes dead for me, because I don't see the patent issued, I don't see it published, I don't see it, nothing. The last part of the trail that I have is at the bottom of the New Energy News article, or it might be the later version of New Energy News, New Energy Times or something. I don't know. But anyway, at the bottom of the article where it publishes the abstract from your patent with Warren Cooley, the abstract, it says at the time of publishing, which was in September 1995, this patent had been bumped up to the Department of Defense and Department of Energy for classification review. Do you know what came of it?
No, I don't think anything happened. Like I said, I've been in touch with the three labs and have not been able to raise an interest. So as far as Warren Cooley and that passed, I mean, we dissolved shortly thereafter, and I haven't heard from him since. So I don't really know what he's up to right now.
So he was the lead on that patent, but like, do you have any explanation or idea as to why the patent wasn't even published? If it was submitted, then
But it was just all theoretical.
right, okay. Well, it's pretty amazing because I'll tell you why. When you mentioned the dynamics there, my journey was okay. I would like to have a solution to the energy problem. And I wanted more children, actually. That was the reason. And
Uh-huh.
I believed global warming, but I thought I have to be responsible about this. And so I took myself in 2012 to ICCF 17 in South Korea, Daejeon in South Korea. And I realized that all these people were seeing similar things. It didn't matter whether they were in a solid system, a liquid system, a gas, or a plasma. They were all seeing the same rough synthesized elements out of the input elements, almost regardless of what input elements were being put in. And that grated with me because a lot of the theories relied on it being in a plasma or they relied on it being in a metal lattice. I thought, how on earth is it possible that you would have all these different inputs, you would have the same outputs, but you would have 70 different theories of how one got to the other? But yeah, it didn't
Huh.
make any sense. There had to be a common framework. And so I kind of believed what I was told I needed to look for neutrons, gamma, X rays, these kind of things up until I actually visited Francesco Piantelli in Italy in January in 2015. And the critical thing he said to me was this: don't tell nature what it is, let it show you. And so from that point on, I changed doing what everyone else was telling me to do to actually looking at what the products of these experiments were under the microscope. And as an open organization, we had samples or we were invited to look at people's technology all around the world. And we started to
Right?
seriously look at what was going on under the microscope. And do you know what we found? We found several signatures, and they started increasingly pointing to hydrodynamics and then more specifically to magnetohydrodynamics,
Right.
and then very specifically to ball lightning. So I don't know what was Cooley's history. I mean, how did he, you're saying it was theoretical, but what was his background to get to, thinking what he
He
did?
he was just like me, an amateur. He didn't really have a background in engineering or physics, but he like I said, he just dabbles in the concept. So I'm just amazed with all these reactions you're telling me about because um I sort of lost track of everything and you have followed on, so I'm truly amazed with your efforts.
Well, it turns out that it really is ball lightning and micro ball lightning. And when Warren Cooley was writing that letter to all those people in 1995 and calling out Hal Fox, who was the editor, but also a major proponent of Ken Shoulders, and calling out the work of Dr. Takaaki Matsumoto, whose book I'm remastering right here.
Ah,
Now, in here, this was with a lead wire. And out of this lead sphere, that is a product of a very short experiment you could easily conduct yourself. This is a plume of carbon coming out of the
uh-huh,
inside.
uh-huh,
And we see this in many experiments. We see these hollow spheres. Hold on a second. We see these hollow spheres, and out of the inside of these hollow spheres comes often predominantly carbon, oxygen, and hydrogen, but also typical stellar synthesis nuclei. And it doesn't matter which system you use, whether it's cavitation, plasma, uh, even palladium deuterium. You get
right,
these kind of things. And in his case, lead with a normal 120 volts and a few tens of millisecond pulses. And under the SEM, you see these synthesized products.
uh-huh.
And he used potassium hydroxide and lead and water, so there's no carbon in there, and he gets massive synthesis of carbon.
My gosh.
Yeah.
Okay.
And so that is he calls it. I'll read you the introduction to his, and obviously this was after your work with Warren Cooley. It's called Steps to the Discovery of Electronuclear Collapse, and his introduction is thus: Far in the universe, nuclear collapses very often take place by the gravitational force after stars consume their fuel. Since the electromagnetic force is about 40 orders stronger than the gravitational force, it should be easy to induce similar nuclear collapses by the electromagnetic force in laboratory. But we never knew until now how to do that. Recently, the author discovered a nuclear collapse which was induced by electromagnetic force in laboratory during the study of the mechanisms of so-called cold fusion phenomena. Several kinds of nuclear reaction were directly induced by the electromagnetic force, called electronuclear reactions. They were so far found to occur in special state of hydrogen clusters. He calls it ionic clusters, but he then says this is also micro ball lightning. The nuclear collapse was one of the most remarkable reactions amongst electronuclear reactions, called electronuclear collapse. Furthermore, very amazingly, completely broken materials by electronuclear collapse were found to be regenerated again to thin tubes and films of conventional elements such as carbon, oxygen, and iron. The latter process was called electronuclear regeneration.
Okay.
So,
Yeah, speaking of,
go on, yeah.
go ahead.
No, no, go on. What's your
Yeah,
comment on that?
speaking of gravity, the interaction of two particles intensifies as the center of mass of an object is approached. Thus, there's a concentration gradient towards the center of mass, thereby resulting in the gravitational field. It creates the suction of mass. So those are all like just simple micromechanics, and that's what I've been able to work with lately. But all these chemical reactions, I mean, these nuclear chemical reactions you described is all pretty much new to me. I haven't been keeping up with it that much.
Okay.
So
So I think I sent you some of the papers by Shishkin, did I not?
Mhm.
So Shishkin worked with a colleague of his, Kurol's, and also the late Dubovik, who died a few years ago, sadly. Dubovik
Uh-huh.
discovered in 1965 and wrote in his thesis in 1967 when he was working at the nuclear city in Dubna, um, about what's called the toroidal moment. And the toroidal moment is effectively created when you have a electric current ring producing a magnetic vector, and you get at least two of those and have them producing a magnetic loop, and that produces a toroidal moment. It's not an electric dipole, it's not a magnetic dipole, it's a separate class of electrodynamics. And this produces vortices. And the vortices, in my view, are able to cohere and condense relic neutrinos and clusters thereof. And they say in their latest work, Shishkin, that all atoms have the nucleus, the electrons, and a condensed cluster of relic neutrinos. And the condensed cluster of relic neutrinos itself is formed of up between 10 to the 9 and 10 to the 11 electronic vortices. And so when you break up, let's say, and they've established through experiment that when you break up a hydrogen atom, it is 2 to 4,000 times easier to split into these three components than any other atom from lithium and beyond. More, you can do it from lithium and beyond, but you need to put in 2 to 4,000 times more energy. In the case of a
Right.
hydrogen, atomic hydrogen, you only need to put in around about 5 eV, which is just above the recombination energy of two atomic hydrogens into molecular hydrogen, which is fascinating because it means that even with a hydrogen torch, as Langmuir observed, these massive over unity events in the early 210s, 1910s rather, which he couldn't explain in the recombination of those gases, he was getting this gain that you're effectively, if you have this ability to maybe split it into these three components. Now, this is an exotic vacuum object of Ken Shoulders or a microball lightning of Ken Shoulders and or Takaaki Matsumoto. And these things can blow up into these vast number of electrons. And when they blow up into electrons, they are repelling from a coherent state, getting their Coulombic repulsion back, and they produce a scalar pulse as they repel each other, become ordinary electrons, and they have up to 10 keV of kinetic energy. And that is given to them by the vacuum
Uh-huh.
because they don't have it to begin with. They have to get it from somewhere. So they suck thermal photons out of the environment. And so they must have given it up when they were condensing. That this is one of those concepts. And this structure of relic neutrinos itself has a fractal toroidal moment. And when you have a fractal toroidal moment, you produce what's called a non-radiating boundary, and it causes a spherical uh, 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 shape where no electromagnetic waves propagate on the outside. And they're saying that the electron keeps its orbital because this structure pulls in a vortex of neutrinos and relic neutrino clusters into the core, and they extract the energy they need to keep the atom in its stable state. And
Uh-huh.
they have this relationship. So you have these things called Q particles, and as if I'm understanding them correctly, they are quantized clusters of neutrinos. You don't specify relic neutrinos. Is that right?
Well, I don't necessarily think of them so much as neutrinos, but just the Q particle is proposed as a fundamental absolute particle that all things are made of. Photons, protons, neutrons, molecules, etc. It's like, say, for example, you're in a mechanical environment of sound, and there's air molecules that transmit sound or waves. This is the analogy for Q particles at the atomic level. It's a base array that is, encompasses everything.
So there is quite a lot of correlation there with what Shishkin, Karols, and Dubovik are saying. They're saying effectively that relic neutrinos, they are the quintessence. They are the smallest subunit. They are the basic. They call them elementary LC dipoles, inductor capacitor dipoles, and that is a superfluid, and it's 1.95 Kelvin, and it's the universal single wave function. Okay, but
Uh-huh.
it's made up of these particles that are all at the same temperature, 1.95 Kelvin. Clusters
Right,
of these, you might like to call them things like axions or whatever. An axion is a cluster of relic neutrinos. They are the clusters are more like a gel medium, and different quantizations of these clusters are able to allow for the propagation of photons as a vibration through them. And because they're LC dipoles, they allow for an electromagnetic so-called vibration to propagate through this gel medium. Now,
right.
you wrote a paper which I couldn't, or on a note to New Energy News, which is almost word for word what I have been saying is the reason I think you could travel faster than light. This magnetohydrodynamic structure interacts with these gel form of this medium, and it's able to pull it out of the way and pull it around and push it behind it, and to a degree suck it up its bum in a little bit and produce a beam that comes out in a very tight beam. But the net result is it removes the thing that prevents the buildup of mass. And you wrote this article where you were talking about mass accretion because of Q particles piling up in front of the thing that's moving forward. Is that right?
That's correct. The Q particles are very similar to the way you explain that neutrinos are manifested.
Yeah. So
But
this is weird. Go
no,
on.
that's all right.
Yeah. So there's so many corollaries, and obviously I drew upon the for many years I've drawn upon the fact that when a positron and electron annihilate, they produce two photons with the same energy, uh,
Right,
180 degrees from each other with different chirality. So
right,
that for me is the single thing that you need to know that matter is wound light. And so
right,
what do you need to wind something? Well, you need the medium over which light travels, and you need the light itself. And this is what I'm arguing that these, so essentially you have these orthogonal fractal toroidal geometries that produce vortices into them. So, like, if you can imagine, you've got one ring, and then you have a ring and an anti-ring, which is literally a yin yang, and that produces a new ring of the next quantization up. And when you have at least three, and you do the standard Maxwell equations, you end up with not the Poynting vector losing energy by dissipation. The Poynting vector is wrapped into a ring. And this was established in Soviet energetics in the Soviet period. And
uh-huh,
I shared this paper, which when I saw enough evidence that some Russians threw in the towel, and they sent me this paper, it was published in the journal Biology of Life in Russia. And it was by one Zverblis. And Zverblis was trying to work out electromagnetic equipment that could manipulate DNA. And
uh-huh,
as such, he was invited into a Moscow basement in 1988. And
uh-huh,
he saw this coil of a coil of a coil. And when they energized it with 30 hertz, and they chose 30 hertz because it wasn't a harmonic of the 50 hertz AC that they had, they then saw an AC magnetic field in the center. And what he found was that when you turn that off, you still get the AC magnetic field. And even if you move the device away, the AC magnetic field is locked into that piece of space for up to 2 days. And
wow,
they call this an electromagnetic phantom. It's basically it wasn't until Freiberger in 2009, working at Slack, I think fairly near to where you are in California, working for the Department of Energy and studying what they call cavity lights that were observed in a national lab in a superconducting chamber, these little balls of light moving around. They didn't know what they were, but he suggested they were ball lightning. And he suggested that he did the same treatment that Zverblis went to one of the head of mathematics at the Russian Academy of Sciences because he didn't believe. He thought he was being, pranked. So he went
Uh,
there, and uh, this guy called Nevesky, he actually published his work again after the end of the Cold War in 1993 into the Russian journal Electricity. And he did a treatment and found that if you have a coil of a coil of a coil, you get a closed electromagnetic Poynting vector. And if you have a coil of a coil of a coil of a coil, you get one that's 90 degrees to that. And if one collapses, it energizes the other, and vice versa. And the reason why that was interesting to something with DNA, who was investigating DNA, is because DNA is a coil of a coil of a coil of a coil. So that's where it came. But anyway, what we found is that these structures seem to be able to cohere matter. And in 1998, Dubovik and another researcher at Dubna called Afanasiev, they showed that in these fractal electrodynamic structures, they produce the Aharonov bomb effect or Bowman-Aharonov effect. And basically, electrons out at any temperature or other ions can be cohered into a phase singularity, like the bottom of a drain,
right.
except they don't go through, they just cohere. And what you end up with is a ring black hole, like a Kerr-Newman black hole. And then this
Uh-huh.
can cohere matter into the core. And so it doesn't matter what the temperature is, they get forced into coherence as they come in through the vortex, and then they get stuck there. And the magnetic strength goes up and up and up and up. But of course, when you've got magnetic strength and you pull in protons, you align the nuclear spin. And when you align the nuclear spin, you then produce the equivalent of a ferrite core in a solenoid. I not focusing magnetic strength, you then start to focus gravity vector.
Okay, that makes sense. The vortices don't necessarily totally combine, they just interact and are in sort of an inertial state.
Yeah, and basically the electrons can degenerate only to a certain ring singularity, and then you're piling more and more in. So the localized magnetic strength goes up. Now, the way this works is when you have a wheel and wheel and a wheel, you do not need. There's a thing that was discovered by Yakov Zeldovich in 1954. I think 54 or 56. And this is called the anapole. And basically, it's a toroidal electric current that has a magnetic oscillation and electric field oscillation 180 degrees out of phase, so that the electromagnetic waves that they collectively emit cancel at a specific boundary. So there's only scalar and vector potentials that exist beyond that. And effectively, it's a spherical space-time bubble with no electromagnetic waves emitting outside. Well, when you have a wheel within a wheel within a wheel electrodynamic structure, and it's a virial solution, it's stable, it doesn't explode and it doesn't collapse, it produces its own non-radiating boundary without having to have this oscillation. It does it because of the way the electrodynamics works. But it does have this net toroidal vortex that feeds itself. It literally has a mouth. And it can suck matter in, and it would appear that the matter is producing energy uh, either by fusion or fission, depending on the elements involved, or by actual synthesis or desynthesis of matter, like either synthesizing matter from winding light or desynthesizing matter from unwinding light. And
Uh,
that drives the magnetohydrodynamic structure. And it needs to feed to live and live to feed, if you know what I mean.
yep.
And weirdly, in many different examples, these structures seem to last for about 2 days. And this is when we come back to your relic neutrinos and clusters thereof, aka Q particles, is that there is a neutrino sphere around the Earth, the Moon, the Sun. And it's denser when you are facing towards the Sun. And so if you imagine you've got enough neutrinos to help you with the process, you might run out. It's like got a hysteresis. It can keep running for about 2 days, but if it doesn't get any more food or neutrinos, it'll die.
Uh-huh.
So it's really kind of it opens up so much magic. But I was totally blown away because that paper, that patent, where you show that magnetohydrodynamic structure, where you say the fusion occurs, that is literally exactly where it occurs.
The what now?
The fusion occurs directly where you showed in that pattern.
Oh, okay. That makes sense.
And I want to know, was that just an intuition point of view?
Absolutely.
Right. But
Mechanical analogies play a big part in my understanding of these things, and that certainly is one.
well, again, I've been editing this video from 1998 of Martin Fleischmann, and he says there must be uh, something that connects classical mechanics with quantum field theory. Quantum field theory helps you to explain particles and particle interactions to high degrees of accuracy. But it must be a classical process that's bridging that gap. And
Right,
magnetohydrodynamics is a classical process. It's a fluid process and so on. It seems to be that bridge, and it bridges through electrodynamics in charge separated material or ionic material in the case of water into
right.
producing this phase singularity, and the phase singularity is where all the magic happens. It's the still quiet calm.
Okay.
And then the really crazy thing is that all of the symbols of power and religion around the world are this same thing. So here's one. What do you think that is?
Looks like a handle.
Yeah, it does look like a handle. Essentially, it's this part on the human anatomy between the there, or over there. It is the Ukon Fasara. It is Thor's hammer, and this is the part of the electrodynamics. If I was to spin that round 180 degrees, that would make like a pentac shape. But this goes down to the bottom of the Vesica Pisces, which is the base part of the magnetohydrodynamic two intersecting circles, right? If you think
Right,
of the Vesica Pisces. And this is the bridge between the half radii and the half radii that produce the inner vortex, which touch in the middle.
right.
Okay.
That's right.
That
That's exactly what.
that is Thor, the most powerful weapon in the universe, according to the ancient Norse religion.
Wow.
And I'll,
It
if
is.
you just hold there, I'm going to show you the most powerful weapon in the Hindu faith. It is this. It's the Vajra.
Uh-huh.
And the Vajra's point of power is in the center. And you have
Right,
a yin and a yang, and they are comprised, the stable comes from at least four. You need minimal too, but it's four. So we have four structures around here. That's most stable. And then in the structure, you see a magnetohydrodynamic vortex here, here, and here.
okay.
So this is a wheel. This produces a wheel. That produces a wheel. That produces a wheel. This is a wheel within a wheel within a wheel within a wheel.
All right.
This is the thunderbolt, also in that religion. Zeus's most powerful weapon, not fire, that was stolen by Prometheus, right, for man. Zeus's most powerful weapon is the thunderbolt. In every religion, and thunderbolt is a euphemism for ball lightning. And Ken Shoulders established this because every lightning bolt starts with a ball lightning. So
He has an invention called an EV. He says it's so simple you can perform it in your kitchen. I
EV,
forgot what EV stands for, but
well, it was originally electrum validium, which means strong electron. He then realized it
right, yeah,
contained ions, so he called it charge cluster. Then he realized it
right,
contained a lot of electrons and a lot of ions in a ratio of 100,000 electrons to one ion, typically. And he then called it a high density charge cluster. That's about the time that Hal Fox was involved. But ultimately, he ended up calling it an exotic vacuum object. And that is to say, it is the same as normal vacuum objects. It's just a fractal metastable structure in our normal vacuum state. And what
Hmm.
Shishkin has established is that these are, in fact, the same thing as static electricity.
So,
Tesla went into the desert with a big copper sphere collecting static electricity. Henry Murray went into the desert with a big flat panel collecting static electricity. John Hutchison, who I have a photo of here, John Hutchison is here, and this is Ken Shoulders here. Ken Shoulders discovered the EVO in researching the work of John Hutchison.
amazing.
And so it is all the same thing. Now, this was on the mantelpiece of Dr. Takaaki Matsumoto, the owl. The owl is the symbol of Delphi. The other symbol of Delphi is the double epsilon. The double epsilon is two half circles that join in the middle with a line that goes to the center line of the edge of the two half circles and a line through the
Mhm.
center. That is the old thunderbolt coin symbol from pre-Christ, from
Mhm.
Macedonia. And that was a symbol of power put on their coinage. And that's the geometric version of the owl. And the owl is the symbol of magnetohydrodynamics. It seems
Amazing.
it seems that all of the ancient world knew that the most important, and if you do the electrodynamics, when you get this non-radiating boundary with this, if you have two, the beams that come out that pull matter in, they will penetrate the boundary and pull matter in, producing the same thing that you get with a normal tornado or a hurricane. But when you get four of them, i.e., the swastika or the salvastika, the swastika takes matter apart, the salvastika assembles matter. One is right chirality, that is the swastika, and the salvastika is left chirality, it's assembling. That is
Right.
the yang and the yin, respectively. Okay.
Uh-huh.
They always work in pairs if the next fractal level up. Okay. But when you have four, the beam actually goes into the apple part of the magnetohydrodynamic structure in the loop when you've orthogonally got it arranged. So the first time that power comes under control is when you have the swastika. Or a different interpretation of it is drawn differently. It's called the Maltese cross. And so if you look at the stele of Shamshad Adad, from 3,800 years ago with cuneiform from another 1,000 years before, it has the perfect the perfect Maltese cross around his neck with a circular black sun in the middle. And it's the interaction of perfectly and exactly the non-radiating boundary of four orthogonally arranged non-radiating boundaries. Six orthogonally arranged non-radiating boundaries is exactly the flower of life, and
Okay.
it's the model of carbon.
Okay, exactly that amount.
And that's when you get the beam goes into the central core, not the non-radiating boundary. It goes all the way into the apple, so it's perfectly stable when you have six.
Mm.
And I believe that we have these experiments where you've got a Mars gas, which is a form of HHO. You put it on tungsten, it produces a perfect magnetohydrodynamic structure, and there is this point. So we are built in the image of the technology that runs the universe. Vortex, anti-vortex, Sothic triangle. Point of destruction is here. When you open your mouth, that's the food. The ratio between the top here of the apple shape and the center line here, and the center line down to the point of destruction, is the golden ratio. The triangle here, the Sothic triangle, if you start at the point of destruction and you draw a circle, and then you draw a circle that's 1 over 1.618, and it produces the vortex, which is the golden ratio vortex. And there's one coming out this way and going in that way, rather that way and that way. And so it's
I see.
fractal, and this explains why you have these golden ratio in everything. And it's when the material gets sprayed out the top in these magnetohydrodynamic structures, they're offset by the golden ratio. And that is because nature it's the highest packing density where you don't have wave interference.
All right.
And so everything stems from that. All of the structures of nature, everything. And I believe because it's so uh, stable, that is why carbon is the most likely product to come out of this electronuclear regeneration process that you observe.
Okay.
Um, and so it doesn't matter whether it's fusing or fissioning. So like if you start off with only light stuff, you get carbon. If you start off with really heavy stuff, you get carbon. And one way you get more than the other. So it almost doesn't matter what you put in. If you start with carbon, then it's like a rock on which you can do your process because it acts like a catalyst. It might take a role in the process, like gathering charge or going around the CNO cycle, carbon, nitrogen, oxygen, with adding protons and going around in a loop and producing alpha particles. But ultimately, you produce three alpha particles, you produce another carbon atom. You see how it breeds itself.
All right.
So you were right on the money. That patent application, I would really like to know why it was never published.
I've had difficulty with publications because they're generally I resorted to publishing on the physics forum right now.
Mm.
And that's not so permanent. You know that can't last forever. I prefer to publish in a journal, but my articles are very simple. They don't have all the fluff that is typically associated with a published article. I just don't have the makeup to be able to produce that sophisticated, elongated article that they're looking for. So I haven't been able to publish anything there, and it remains to in my um, physics post, the physics forum. There's about uh, 160 comments. I can't remember how many comments there are, but those indicate the various proposals that I have that's buried in that stream of replies on my physics forum article. So, and word of mouth, like with you, that's the best I can do.
Yeah. Have you got any passion or desire left to try and make an experiment to demonstrate some of these effects?
Only in that I described the basics that could be put into an experiment, like for example, the the fusion. Um, but you have described countless ways that I would have approached these by other researchers. And these are researchers that can publish in journals. So I tend to think they've got something going.
Well, the most easy way it would seem to produce this effect is through resonant sound and
It's through what?
resonant sound in water.
Okay.
And if you want to do an experiment, we have a just to see. It's called Ultra. It requires you to be at least 5 years old and up, but I think maybe a 3-year-old can do it. It takes about 7 minutes. It takes about 7 minutes to conduct, but you do have to invest around about 35 US dollars. Um, you need to have the skill of being able to pour water full Reynolds wrap and press one button. Oh, you have to plug it into the mains as well. It uses 43 kilohertz sound in a 30-watt transducer in a basic ultrasonic cleaner. You wrap the foil in such a way that it stands in the water column with a hard reflector slightly above it. And basically, the sound is produced up, it gets reflected off, and you get standing waves that moves the foil into nodes and antinodes of the standing wave. And transverse to that, you get perfect peaks with a cone, cones with a cones with a crater and craters with a cone in exactly the yin yang structure. And on one side, you get lighter elements synthesized and you get like a blooming of lighter elements. And on the other side, you get heavier elements synthesized and part of the aluminium removed. You can see it with 200 times optical microscope. You can use chemical analysis to see the elements synthesis in there. And it's the most simple form of cavitation-based element synthesis and desynthesis. And for references on more advanced versions, you can look at Leclerc's work in the early 2000s. But I think the most important work was done in the 1980s and 1990s and into 2003 when he died by a guy called Kladov in Russia. He had two patents in 1983 for heat generation. No one believed him then. And then
Uh,
from 1998 to 2003, he produced cavitation destruction of matter, where he
uh,
showed that starting with water and sound, he could produce in a number of hours like 20 elements and a number more hours and like 30 elements. And then after 350 hours, he had 55 new elements synthesized. Of course, it's kind of like the yin yang, they feed on what's available to them. And so if you've made some heavier elements, then that's your starting product. If you've made some lighter products, then that's your start. So you get a mix and it kind of continuously blends. And it's very well described. They didn't believe him then. And it wasn't until 2006 and separately in 2009 that the Russians had run out of nuclear, biological, and chemical material to destroy using their hydrowave technology, which was an
mm,
electric arc discharge in a water jet, went into a stator and a rotor, and the rotor was shaped with, and the stator was shaped with waves that kind of broke, that decayed, I think, with the golden ratio. So they went wave, smaller, smaller wave, smaller, smaller wave. And this span round. So you've got all of the cavitation frequencies as the water is being ejected through the plate and the rotor and the stator. And this was to destroy biological and chemical weapons without any release into the atmosphere. It would just break down the chemicals. So they completely destroyed. When they ran out of things to destroy, they decided, oh well, should we see if Kladov had any truth in what he was saying? And Kladov had shown an incredibly fast reduction in the activity of cesium-137 within a few hours in his system. So they tried strontium-90, yttrium-90, and they again massively reduced it. And the interesting thing with all of these elements that seem to be easy to reduce, they are beta isotopes. And they get reduced, it would seem, by the weak force. The weak force is
uh,
mitigated by neutrinos and
uh,
radical neutrinos. And I translated a Russian scientist book in 2019 called um, Alexander Parkhomov, and he established that there is this flux of relic neutrinos that come down and they can be technologically lensed because they are wavelength, the Broglie's wavelength, because they're extra low energy of microns to millimeters. They can be focused on, in his case, he used cobalt 60, 1 millimeter by 1 millimeter by 1 millimeter. He used discrimination with aluminium and he could see the Emax. So and when a normal beta decay, it goes, all kinds of energies are shared between the electron and the antineutrino. And then you have Emax, which is the maximum where zero energy is given to the antineutrino. Well, when you have inverse beta decay or reverse beta decay rather, that is when a neutrino is coming in the left hand side of the equation and annihilating the antineutrino, and the electron gets emitted with only Emax. So he discriminates for that so he can see the signal from the noise, and he shows that there is an annual cycle. So when the northern hemisphere, he was in East Moscow, was closer to the sun, it's going through a higher density of the neutrino sphere of the sun. And so you have an increased beta decay rate with the focused relic neutrinos. And so this is what's happening in the cavitation of water. The you are getting these neutrino fluxes focused to the point of the material, such that the reaction probability goes exponentially up, and so you end up with matter synthesized, desynthesized, depending on whether you got a yin for synthesis and a yang for desynthesis. And in the case of a yin, you will use, oh God, let me get this right. Uh, you will need to make beta particles. So you need, anyway, you need a neutrino, I think, and then an antineutrino. You need an antineutrino for a yin and a neutrino for a yang. I think that's right.
okay.
Because basically you're either building neutrons or you're decaying them in order to build
Okay.
heavier atoms. And so I think you're right on the money with your thinking in terms of neutrinos and clusters thereof. Um, he has found that any matter that's over 1,000 degrees can start to synthesize through kinetic interaction these
All right.
relic neutrinos or equivalents thereof. So you do not need a Big Bang. You do not need a supernova to produce these things. You can produce them technologically. And obviously, if cavitation bubbles have been estimated to be well over 5,000 degrees, the temperature. So the actual cavitation bubble itself is able to produce these relic neutrino fluxes, as well as produce the vortice which holds them. So if I can, I'd like to send you this what we call the Ultra experiment, ULTR. It's very well studied. The products are well studied. They produce the same kind of synthesis. I'll also send you the very simple experiment by uh, Takaaki Matsumoto. You need a wire, and it needs to be a thin wire, ideally, because that
Right.
creates the pinch effect. And when you have the pinch effect, you also have vortices. But in the video recordings he made in the early 1990s, he put a microscope objective on the front of a nice video camera. So he's actually got 720 by 480 lines or something, or 640 by 7. Anyway, it's a normal high quality Sony camera, but he's only looking at like 1 or 2 millimeters in perfect focus.
Uh,
So you can literally
okay.
see where these explosions occur in the palladium deuterium or the lead and you can literally see the magnetohydrodynamics, the mushroom clouds coming out. And it's just like, why did no one else think of doing this? He did it in the early 1990s. You can literally see the hydrodynamics going on.
Right.
So normal electrolysis is actually also cavitation,
Right. Uh-huh. I see.
which has all of the ensuing hydrodynamics involved and multi-phase system. It's amazing.
All righty.
So those are the
Okay.
two simple experiments, but it's very interesting and fortuitous that I'm able to reach you today because today, literally, I have been informed that U.S. Department of Energy and or the ARPA or something, they are literally saying cold fusion. We want to support cold fusion.
Oh my, that's profound.
I should have opened with that, but yeah, yeah.
Absolutely profound. It For a long time they just wouldn't even say the word cold fusion.
It's got embarrassing now because like I worked with this guy in Taiwan and I predicted that in the system he would produce from oxygen 16 and hydrogen, he would produce oxygen 17. And then I said that the oxygen 17 would fuse and fission and they would produce a neon isotope and carbon 12. He's seen in many, many experiments high enrichment of oxygen 17 and the synthesis of neon 22 in exclusion of 20 or 21. And it's the rarest isotope of neon. So it's a slam dunk case. It's a slam dunk case. The
All right.
original George Osawa experiments, if you rethink it, because they never looked for helium, they just assumed that helium would have been the product, and it was like two carbon 12, two 18 oxygen, fuse and fission to four helium and iron 56. But if you actually look at it as four protons fusing with four oxygen 16, making four oxygen 17, they all fuse together and they fission to carbon 12 and iron 56. It's almost exactly the same energy that they observed thermally increasing over the electrical input energy. So the same process seems to be going on that would go on in natural ball lightning.
All
So
right.
yeah, we're at a stage where this is now a science. It's repeatable, and that work with the original paper showing those predicted synthesized elements was published in Nature Scientific Reports on January the 2nd, 2024, and it has spawned a lot of interest. Let's put it like that. I then predicted in 2022 that in cavitation, a fractal magnetohydrodynamic structure would produce these apple-like structures, which would be the working thing in a cavitation system. That was in 2022. I said that again to my colleague in Taiwan in late December 2023. On the December the 2020, 2023 on the 29th, he gave me a sample from his reactor. And in early March 2000 or March 2024, I analyzed that sample. And that is, we found thousands and thousands per square millimeter, or square centimeter rather, of these apple-shaped magnetohydrodynamic structures. And when they died, out of them came two more structures. And when they died, two more structures came outside of those. You can literally see the big one dying and the virial solutions that made it coming out. And when those virial solutions come out, it's again producing these things coming out. So that is the wheel within a wheel within a wheel structure. And when these things die, they also they throw out a volume of synthesized material or captured material that couldn't possibly fit inside these structures, which means they have to be coherent inside. So I encourage you to go and look at that video. It's called Flux Capacitor. I think I sent you the link already, but
Okay.
it shows how these hydrodynamic structures, specifically magnetohydrodynamic structures, are able to cohere matter, cause the matter to collapse, and to be reborn as new matter, just as you showed in that patent. Well, you didn't. You talked about the fusion, but you were so close in terms of understanding, the basic understanding.
Great. Okay.
So where do you want to go from here?
Let's exchange emails. I'll send you my
Yep.
email
Cool.
address, and yeah, let's. I'd be really interested in getting some of your inputs again. So I'll send you my email address, and we'll take it from
Wonderful.
there.
Wonderful. I will be over in California, hopefully within this quarter, but possibly at the start of the next quarter. I will be doing some research in Santa Cruz. I was wondering if it was possible to come up. You around there, or
Oh, I don't really travel, so
no? I mean, if I came to you,
oh yeah, that'd be great. Love to have you.
wonderful, excellent. And then I can show you some of our things, our physical items.
Okay, I'll
Cool.
go for that. So just keep me in touch, and we'll plan on it. You can just come to the house here.
Wonderful, wonderful. I very much look forward to it. Chuck, thank you for listening to me, and thank you for clarifying to the best of your ability, what happened to that patent in the 1990s. I do wonder whether it was actually classified, and maybe that, was there any other reason you could give for, dissolving the company that that might explain it better?
Well, not really. Um, the company, they said, "What do you want to do with this?" I said, "I want the patent rights," and so they said, "Yes." So I've got the rights to it, as opposed to an employment agreement with them, and that was what enabled me to elaborate on it further.
Right. Okay. So, but where was it published? Was it published? The patent?
Oh, not really. There was never a patent issued. It was an idea that uh, the nuclear fusion candle was the title of the
No,
invention.
no,
It was
no. I
just,
don't mean the nuclear fusion candle. I mean the one with Warren Cooley.
oh, no, just with New Energy News. That was the extent of it.
So you didn't actually submit the patent.
No.
Right. Okay. That explains that. So I've been under the impression, because in UNG News that they said that this has been bumped up for classification, that it had been classified, and so I need to correct the record on that.
Okay.
Okay, so that's good. We've established that, but it's just such a shame because you guys were so close so soon. And
Well, that's,
we're at a point now where everyone's saying we need cleaner energy, we need more energy, and we now know that these processes occur. We can repeat them at will, and so and now we've even got the U.S. Department of Energy and/or Defense saying, okay, we want to start trying to see if we can make working devices from this. I
all
think
right.
it might be our time.
All right. Okay.
Wonderful.
All right. So we'll look forward to seeing you when you come up.
Thanks, Chuck. I look forward to it. We'll keep in touch and I'll send you some links.
Great. Thank you so much, Bob, for all your elaborate disclosures of everything. Sure appreciate it.
Chuck, thank you for your work. It was very inspirational to read.
Great. All right, Bob, we'll talk to you soon.
Bye now.